Okay, so starting with some detailed questions, explain in terms of molecule why it is possible to compress a gas but not a liquid.
Because there are weak attractive forces between the molecules of gas.
Yes, so weak intermolecular forces. So that is the one concept. And what will be the second? Molecules are far away from each other, right? So there are much empty space between the gas molecules. So that's why we can easily compress gas as compared to liquid.
Yes.
So molecules are away or far away from each other. So due to empty space between the gas molecules, it is easy to compress the gas molecules as compared to liquid. And two containers made of insulating material contain the same volume of water at room temperature. The containers do not have lids. Okay, so they are made up of insulating materials. Volume is same at room temperature and they don't have lid over the surface. The volume of the liquid in each container gradually decrease. After a certain time, the temperature of the water has decreased to below room temperature. Explain in terms of molecules why the temperature has decreased.
Will we explain evaporation here?
Yes, so that is related to evaporation because energetic water molecules will escape from the surface of the liquid.
Yes.
So energetic water molecules escape from the surface of the liquid, leaving the low temperature molecules in water that will decrease the temperature of the liquid, right? So that is simply the explanation of evaporation, right?
Yes.
Or one of the containers is wide and shallow. The other container is narrow and deep. So predict which container has the greater cooling rate of cooling. Explain your answer.
Will it be the wide and shallow one?
Wide and shallow because area is directly proportional.
To pressure?
They are
No.
talking about rate of cooling. So we talk about the concept or the factor affecting the rate of evaporation. So if we are working with the greater area, so it means that we are having a
Greater rate of evaporation?
separator rate of evaporation or cooling. So in wide and shallow container, the rate of cooling is greater because the rate of evaporation is directly to the area of the container. Okay.
Yes.
Okay, so that was question number one. And question number two, state what happens to the molecules of a gas in a sealed container when the temperature of the gas is increased.
The molecules gain energy
Okay,
and they collide more frequently with the walls of the container.
okay. So kinetic energy of the molecules will increase or their collision with the wall will also increase, right? So multiple options are there, but we have to write only one because of 1 mark. So a quantity of gas is contained in a sealed container of fixed volume. The temperature of the gas is increased. State in terms of molecules two reasons why the pressure of the gas increases.
Because the temperature increased.
Okay, so first concept is because the temperature will increase, right? Because of increase in temperature. And the second,
The molecules gain kinetic energy.
yes, kinetic energy or the molecules gains kinetic energy and collides with the wall more frequently. So these are some factors that why the gas or the pressure of the gas increase, right? Okay, a helium-filled weather balloon is held at ground level. The volume of balloon is 4,800 meter cube. The pressure of the helium is 98 kilopascals. Balloon is released and rises to a height where the volume of the balloon is 7,200 meter cube.
Is it P1 V1 divided by P2 V2?
Yes, so that is simple relation P1 V1 is equals to P2 V2. So we have initial value that is V1 48, right? This is V1 and this is P1 and the volume of the balloon this is V2. So we have to find out the new pressure that is P2. So P2 will be equal to P1 V1 divided by V2.
I'm getting 65.3.
Okay. So 98,000 multiplied by 4,800 divided by V2 is 7,200. So you are getting,
Oh no, it's 65,333.
okay, so 65,000, right?
Yes.
Okay, so we are getting 65,000 pascals, or we may also write as 65 kilopascals, right? And suggest why it may be necessary to release helium from the balloon as it rises even higher.
Because it could burst.
Yes, because it could burst, because pressure will increase, so it could burst the balloon. So that's good to prevent. the balloon bursting, or second, to reduce the pressure inside the balloon, right? Okay, question number 3. A student carries out an experiment to find the relation between the pressure and the volume of a fixed mass of gas. The table contains four of her sets of measurements. Pascal, that is pressure and volume. Use the data in the table to suggest the relation between the pressure and the volume in this experiment. Explain how you reach your conclusion.
As as volume increases, pressure decreases.
Okay, so we are increasing in pressure. So the value of the volume will decrease in the question. So pressure is inversely to the volume of the gas according to the Boyle's law, right? Okay, so according to the Boyle's law, pressure is inversely proportional to the volume. And if we talk about some other factor, if pressure increase, so the volume of the gas will decrease, right? Okay, question part 2, state the property of the gas apart from the mass that remains constant during the experiment.
Temperature.
Temperature, because that is also included in Boyle's law, that temperature remains the same. So pressure will inversely proportional to the volume. Now lake is 5 meter deep. The density of water is 1000 kg per meter cube. Calculate the pressure at the bottom of the lake due to this depth of water. So you have to calculate the pressure at the bottom. And if you remember the concept, so that is basically related to the chapter pressure. And in the chapter of pressure, we studied that pressure in liquid is equals to density, gravity, and height. So P is equals to rho GH, that is the formula. So we have to use that formula over here. So density is equals to 1000 multiplied by the gravity, that is equals to round of 10, multiply the height or the depth. So depth is equals to 5.
It's 49,000.
49,000 if we are using 9.8, right?
Yes.
And if we use round of value 10, so that will be equal to 50,000.
Yes.
Okay, we will continue after the completion of a term, right? Okay, question part 2. A bubble of gas escaped from the mud at the bottom of the lake. and rises to the surface. Place one tick in each row of the table to indicate what happens to the volume, the mass, the density of the gas in bubble. Assume that no gas or water vapor enters or leaves the bubble. So if we talk about the volume, the volume of the bubble will increase, decrease, or stay same.
Decrease?
The bubble of gas escapes from the mud at the bottom of the lake and rises to the surface. So it means a bubble of gas is rising to the surface. So it means the pressure will decrease on it, right? Because it is moving from the bottom to the top. So it means that pressure will decrease on it. So it means volume will increase, right?
Oh, yes.
And if we talk about the mass, the mass remains the same. And the density
Decreases?
decreases because again, that is the same formula for density and volume. So we are increasing the volume, so density will decrease, right? Okay, question number 4 shows a gas contained in a fixed enclosed cylinder, sorry, enclosed by a piston. At first, the length of cylinder containing the gas is 100 centimeter. The pressure of the gas shown by the pressure gauge is 300 kilopascals. The area of cross-section of the cylinder is 0.12 meters square. Describe the motion of the molecules of the gas.
They have a lot of energy, so they move randomly throughout and collide more frequently?
Yes. So they are going to move in random direction. So molecules move in random direction and the speed of the molecules will be greater, right? And they also collide with the walls and each other. And use the idea of momentum to explain how the molecule exerts a force on the wall of the cylinder. So we know that momentum is equals to mass multiplied by volume. So that is the formula of momentum. And when we are talking about the momentum, so when a particle collide with the wall, so it will rebound or it will bounce back. So we can write it as with respect to the collision, that collisions with the wall causes change in momentum for the molecule, right? And if we talk about the second definition of momentum, so second definition for momentum will be like this, that force is equal to rate of change of momentum. So we are talking about the force. So if force will increase, so it means that momentum with respect to time will also increase, right?
Yes.
So rate of change of momentum is equal to the force. So increase in force will also increase the rate of momentum, right?
Yes.
And part B, so in part B, the piston is moved so that the new length of the cylinder occupied by the gas is 40 centimeter. Initially, we are at, I think, 100. Yes. So the temperature of the gas is unchanged. Calculate the new pressure of the gas. So we have to calculate the new pressure. So that is also very simple. If we talk about with the reference of initial values, so initially we are having values. Initial pressure is mentioned over here, that is equals to 300 kilopascals. That is the initial pressure P1, and the area of cross section of cylinder is also given, that is area 1, and length is also mentioned over here, that is 100, right? So you know the formula, that is P1 V1 is equals to P2 V2, but now we are having indirect value of volume. So we have to multiply 100 into 0.12 to make the volume, right? So volume will be equal to area multiplied by length, but the only difference is area is given in meter square, but we have to convert the length into meter. So that is 100. So it means that we have to divide it by 100. So that will convert into meters. So 100 divided by 100. So that will same equals to 1. So it means volume will be equal to 0.12 meter cube, right?
Yes.
So that is volume 1. And pressure 1 is 300 kilopascals. So it means P1 V1 equals to P2 V2, and P1 is equals to 300 uh, kilo, that is 1000, and volume 1 is equals to 0.12, and we have to find the new value of pressure, and the next length is 40 centimeter. So now we have to multiply the area, that is 0.12, multiply by new length. So new length is equals to 40. So we have to convert into meters, right?
Yes, it's 0.048.
0.048. So we have to multiply these two quantities, and then divide by 0.04.
048.
Okay.
It's 750,000.
Okay, 750,000 means 750 kilopascals, right?
Yes.
And explain in terms of behavior of the molecule why the pressure has changed. Now,
Because the molecule.
yes,
There has the pressure increased or decreased?
pressure is increased because initially we have 300,000. Now we have 750,000. It is now almost greater than the double value. So because we decrease the length, right? So piston moves inward, or it compresses the gas molecules. So that's why the pressure will increase, because in the second statement, we are having new length equals to 40 centimeter. Initially, we are having at 100 centimeter. So we decrease the length. So that means the pressure on the gas molecules will increase. So now we can simply say that molecules collides with the wall more frequently, and the greater force per unit area will applied on the wall of the container, right? So that is the concept. Okay.
Yes.
So I think questions are not much difficult. So you may try to solve the questions. So mostly are related to the theoretical part. So we will continue in next class with the next chapter. Till then, you try to solve the remaining question of this worksheet. Then we will continue with the new chapter, that is thermal process. So then after that, we solve the remaining question of this worksheet, also the new question from the next chapter, right?
Okay, sir.
Okay.